Hi, welcome to this presentation on feature flags and phase rollout. I'm Kristian Larsson from the NSO CTO team, and today I'll take you through one of the aspects of lifecycle management in NSO with services. And in particular, we're going to look at how we can introduce changes in a controlled fashion. We're going to do this in two parts. So this first part is going to talk through the basic scenario or the problem statement, if you will. We'll look at how we can solve that using feature flags. And then in the second part, we're going to look at this thing we call phased rollouts. Okay, so for the first part, controlling change. So I'm going to run through a rather common scenario here. So let's say it's day one, right? You build a service. This service is for configuring your backbone interface in your network. So it's the thing that you use to connect your routers together. It's going to configure an IP address, or maybe two IP4 and IP6 on an interface. We're going to configure some form of routing protocol. Perhaps multicast and other things as well. Anything that you'd have on a typical backbone interface. So it's a fairly standard and basic service, right? We're going to use a configuration template to do this. Now, on day two, the second day, you start using this service in your network. You roll it out. You'll have a couple of hundred instances, and everything is fine. Everyone's happy, right? Then day three comes along, and someone is like, "Hey, would be really cool if we could use jumbo MTU in our network." Okay, so that means we have to change the MTU from 1500, which is the default, to being 9100 instead. Now, we didn't even cover this in our configuration template because we just used the default value. But nonetheless, this is something that's sort of a hard-coded value, although it has the implied default value. We need to change our service, but how do we do that? And how do we do that in a controlled way? I think there are, at least two approaches to this. So the first one is what I call the naïve approach, and this is sort of the default really that you get with NSO. So as soon as you change a service template and you redeploy a service, this is the sort of behavior that you get. NSO will just figure out the changes that need to be done and will act accordingly. The second one is the feature flag approach, and that is really what this presentation is about. So we'll get to that shortly. Our service uses a configuration template to configure certain things on the device. So if we want to make changes to the configuration that we have provisioned, all we have to do is make a change to the configuration template and reload this in NSO by doing a package reload. After which we can redeploy a service, and this will push things out. So NSO will figure out the changes that are required to go from one version of the package or the configuration template to the next version. And this is really one of the very fundamental features in NSO. And it might even be the reason why you're buying NSO. And since it is, we just assume that this is also the way we should always be making changes. I don't think that's necessarily true. But nonetheless, if we're doing the naïve approach, this is what we're going to do. Change the service configuration template, right? After that, we commit our changes to Git. I hope that you're using a Git or some version control software to keep track of all your code, your service templates, etc. And as we push this to our code hosting server, it will hopefully also go through a CI testing system with various test cases and so on. Once that's passed, we proceed to deploy our new version of the NSO service package to our production NSO system, after which we can run the redeploy on the service instances. And at this point, we now have our new configuration being active in the network. So the configuration that we've added or that we've changed here are on line 15 and 16. So before we didn't even have this MTU configuration stanza, we just relied on the default. And now that we want to go to 9100, we've added this value, right? Now, doing a naive change like this means that we keep down the number of test cases. So that's generally a good thing, right? So previous to the change, we tested for the MTU value of 1500 and made sure that our services worked with that. After the change, we simply have the same test case, and since it's configured 9100, it's now going to be tested using the new value, right? This keeps things simple, and simple is good. We don't get any extra test cases here. It's the same before and after the change. And if we just think of test cases, right, and how it relates to the number of inputs that we have to a service, we have to really sort of be careful here. So I've written down here on the right side, we have a single Boolean input to a service that has two different values, false or true, or potentially a third being sort of null if it's not set. But let's just ignore that for now, right? So it's two values. That leads to two test cases. We have to test both of these values, right? If we instead have two Boolean inputs, that gives you a total of 4 test cases to cover everything. If you have 3 inputs, that's 8 test cases, 16, 32, 64. I mean, you see where this is going, right? You probably studied binary. So how many different test cases do you want to implement for your service? Is it 10? Is it 20 or 30? I mean, usually the sort of level we're able to reach with a reasonable effort is quite low. I mean, maybe we can talk about 10 test cases or maybe 20. So that leaves us with something like 3 or 4 input Boolean inputs to a service, or otherwise we've sort of gone past our test budget. So this is why it is so important to keep down the number of inputs to the service, because we have to be able to test the service with a reasonable effort. Now, testing isn't the only aspect, though. I mean, perhaps more important for operations is what I call the loaded gun scenario, and this is something that you will most definitely want to avoid. So the loaded gun scenario happens, I mean, the gun is loaded from the time that you do a package deploy up until the time that you do a redeploy of your service instances. Anywhere in between here, this is where the loaded gun or the gun is loaded. Your service, from the time that you've deployed the package, your service is going to be out of sync. All your service instances, right? If you go to a service instance, you do a request, blah 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 service, and they do a checksync, it's going to say out of sync. So and that is because the service definition has changed, but you haven't yet run a redeploy, right? So anyone coming in and doing an unrelated change to the service in this time span will also deploy your change, whatever that is. So this is dangerous, and this is why I call this the loaded gun scenario, because it's just as if you would take a loaded gun and place it on someone's desk, just waiting for your colleague to come around and sort of accidentally fire it. So let's just run through that, sort of how it works out in reality, right? We have our engineer here. He's written a new version of his service, and he's done a package deploy. Now, before he's able to come in and do a redeploy of all these service instances, our guy Andy here comes in, and Andy, he wants to fix a small spelling mistake in a service instance. He considers this to be a trivial change, thus he doesn't do a commit dry run. Instead, he just does a commit. And so now what he's going to do is not just push his change, which is a harmless change to the description. He's also going to push the new MTU configuration, and that's going to cause a service outage. So big bada boom, our engineer isn't very happy at all, got a headache, and Andy's all like, whoops, he didn't mean to, but Andy inadvertently pushed more configuration than he thought he would. So this is why the loaded gun scenario is really bad. If you're a small team, perhaps this isn't much of a problem, but as you scale out, and in particular, if you have changes that need to be sort of slow, you won't deploy them overnight, but you will deploy them over a long period of time. Perhaps there are customers involved that need to be synced up. Then that time period is going to be all the longer, right? And that increases the likelihood of something bad happening. So the next problem that we have with the naive change is that there's essentially no revert. If you think of a template change plus a redeploy, that moves you forward, right? So there's no really way to go back here. Again, we done modifications to our package. We do a package deploy to NSO. So we have our new service version being active. Then we do a service redeploy. Now, doing a redeploy means we push new configuration to the device. we have to look at if our changes are good. Does it result in the right behavior from the service? So let's say we log in and we look at various statistics of monitoring data and to determine this. Meanwhile, someone else comes in a completely unrelated part of the network, in a completely different service in NSO, and performs some change. Now, a minute after that, we actually determined that our change that we did, that wasn't a very good change. We want to roll back. Now, we want to roll back to just before we did a service redeploy. And per default, the rollbacks in NSO, they act on a global state, right? So rolling back to just before our service redeploy is also going to roll back that other configuration change that someone else did, which is obviously not what we want. We want to keep his or her changes while still rolling back ours. And this is a challenge. Now, there is something in NSO called selective rollback, which you can use for this. And I really do urge you to sort of check that out, because that's a good thing to know about and have in your tool chest anyway. But selective rollback is optimistic. There is no guarantee that it will work. And this is because of the sort of fundamental nature of NSO. So NSO is a strictly consistent system that's using a Yang schema to validate all the data in the database. And so everything always has to be strictly consistent. Now, if there have been other movements in the configuration and data, it might not actually be possible to roll back selectively. Because if you're just trying to undo one change, that might mean that the resulting data that you have will not validate against the model. And this is why a selective rollback have to be optimistic. It has to be best effort. It is theoretically impossible with a strongly consistent system to guarantee that a selective rollback will work. The next problem that we have is something that I refer to as feature grouping. So let's say that we implement feature A and B in our code base, and we merge to master or trunk and deploy our new NSO package. Now, if we redeploy the service, we're going to get both the A and the B feature, right? It's impossible to selectively enable either A or B. So if either A or B causes problems, we need to roll back, and that's going to roll back both of them, right? We can load an older version of our package and redeploy again, and then we'll get the old behavior. But like I said, that's going to roll back both the A and the B feature. So what happened here is that feature A and B have inadvertently been grouped together. And as a result, development time is tightly coupled to operations. What I mean by that is it is at the development time that you choose. You essentially choose a development time when you merge this to master in what order they will be deployed, right? So you don't have the choice of develop them in an arbitrary order and then deploy them in a certain order. The deployment order have to be the same as the commit and merge order. So that's why I'm saying that we've tightly coupled these things. If you're in a small team that's doing both the development as well as operations, so a classic DevOps team, then this might be fine. But as you scale up, it's likely that you're going to have people that are slightly more ops and others that are slightly more developed. And it's just to make that scale well, you want to decouple them and not have sort of synchronization points between these two groups of people, because that's just going to slow things down. And this is why I'm saying we don't want to tightly couple them. We want to have loose coupling. So to sum up, right, we want to allow for reasonable testing, or rather we want to allow for testing with a reasonable effort. And in order to do that, we have to avoid that combinatorial explosion of test cases that we get if we have a large number of inputs. We want to avoid the loaded gun scenario. We want to avoid we don't want to avoid, we want to be able to go backwards or have rollback. We want to avoid the grouping of features, so we can just enable them individually. And in general, we want to have loose coupling between development and operations. And I think the answer to pretty much all of these questions is feature flags. So Feature flags is a rather well-known concept in software development. With feature flags, we move the introduction of a change from the commit or deploy time to runtime. So we get a temporal decoupling of development operations. We decouple them in time, right? We can do development whenever we want, sort of, and once we're done, the operations can decide at what point in time they actually want to deploy these features, right? So that's what the temporal decoupling is about. And feature flag is very much focused on a transition or a change of something, and they also have a limited lifetime. And we're going to look at what just that means. So here's an example of a feature flag, right? We have this list of backbone interfaces. So that's our service, right? That's keyed on device and interface. There's a bunch of configuration here that goes into the service, like IP addresses or IGP metrics, things like that. Then we've created a container called feature flags to make it easier to organize, right? We just have a single feature flag in this case, and it's called highMTU, which is a leaf. It's of type Boolean with a default value of false. So that means when we add this feature flag to a service, there are already deployed instances of the service. So when we start out, all those, when we introduce the feature flag, all those existing services are going to get the default value, which is false, right? And if we read the description, we'll understand that the false means we disable this feature, and that means we get the old MTU. So that means just when we introduce the feature flag, there will be no changes to the network, which is just what we want, because we don't want to start by breaking things, right? Now, if we enable it, on the other hand, then we'll get the new higher MTU, which is 9100. There is a strong emphasis on this transition from old to new with a feature flag like this, which is exactly what we're looking for. Also note here that the feature flag lives under the service, so there's a feature flag for each service instance. And this is important because we want to be able to have that control on a per service instance to enable or disable this feature. And as we'll see later, this is also the foundation of phase rollouts. This is what the configuration template looked like. We saw before how we added that MTU leaf and had a 9100 value. This time around, we now added a condition. It's a when condition. So this is only going to be present, this whole MTU stanza, when the this XPath evaluates the true. So it checks that feature flags /high MTU equals true. And this is, of course, rooted at our service instance. So it's just going to check that feature flag and make sure that, yeah, if it's true, then we'll use the value of 9100. If it's not true, then it's going to be 1500, right? Now, from NSO's perspective, a feature flag doesn't look any different from any other input. So NSO won't treat it differently. It's, like I said, just like another leaf, right? The difference here is in concept of how we humans apply this, how it behaves, what we expect of it, right? So I'd call it a socio-technical sort of concept. Unlike other leaves, there is a clear life cycle for feature flags. And we introduce a feature flag for a change transition. Once we're done with the change transition, we're going to remove that feature flag. And this is what keeps down the number of inputs and permutations over time. If you have other configuration leaves, those could be more or less, permanent. You introduce them and they exist for the entire lifetime of that service. And those are things that you want to leave to the operator, the user, to configure on the service. But feature flags, they are specifically for transitions, when you want to change the sort of default behavior of a service, or things that are otherwise not configurable, right? So this is what the normal life cycle of a feature flag could look like. So over here on the left side, this is where we introduce the feature flag. It's going to have a default value of false, so we don't actually change anything. We start by doing a canary, so that's a single service that we change, or a few services. We make sure that works well. and with whatever feedback mechanism we might have. And if we do see that it does indeed work well, we're going to start the phase rollout, and slowly but surely we're going to enable this across our network. And at some point, we're going to reach 100% deployed. So all the instances of this service that we have the new feature enabled, right? I've written here 2 months. This is entirely, subjective, right? Or an arbitrary. If you have, I think this depends pretty much on the kind of feedback mechanisms you have. So if you have very good feedback and monitoring, perhaps it's an internal service that you yourself are the user of, then you can do this very quickly. You can do it in 2 hours or even 2 minutes, right? But if you rely on an external party, so if these are customers, and when you change something, you might break something that takes a long time for someone to notice, or they notice it and then it has to trickle through support. They have to understand it's a problem with the service provider, and they have to call support. Support has to realize it's a change, and et cetera, et cetera. Or maybe you have to synchronize all of these changes with the customers. You have to put it in planned maintenance windows, and that's another reason why you can't just change everything in 2 hours. It might take a long time. Regardless, let's say after these 2 months that we have enabled 100% of the instances that we have. At this point, we can now change the default value for these services to be true. So if there are any new service instances created, then they will use the new feature. And for another time period here, again, I wrote 2 months, but it's an arbitrary time period. We have this, feature being enabled for all instances, but the feature flag is still there. And this gives us the ability to disable the feature flag in case we need to do that for debug. And that's, operationally, that has shown to be wise to sort of leave it in for some time. Finally, when we're certain that this feature works as it should, then we can remove the feature flag. And this is also the point that we can remove the old code path when the feature flag is disabled, and we can remove any extra test cases. Now, just like we've looked here at what a feature flag should be, I think it's good to contrast that what it should not be. So these are sort of the anti-patterns. We looked at the feature flag where we called it a high MTU, right? What you could do instead is you could simply add an MTU leaf to your service. So that's what we've done here. No feature flag container or anything. We just have a leaf called MTU. It's a type uint16. It has a range between 1500 and 9100. So this gives the user the ability to choose any MTU that they want. And now it's up to the user to make sure that it works. I think that this is bad because if you actually want to prove that something works in your network, you now have to add test cases. And obviously, we've just allowed something like, I can't count now, but it's thousands of test cases, right, to cover actually every value in between here. And we don't even want someone to be able to configure an MTU of 4000. That's nonsensical, I'd say. So too many test cases, the value range is too broad here. We want to reduce the choices. It's going to be 1500 or 9100. That's the first thing. And here we've done exactly that, right? We've reduced the choice. The range is not 1500 to 9100. It is now 1500 or, that's what the pipe here means in a Yang range. So it's 1500 or 9100. Still, this is a new configuration knob. And if we just introduce more configuration knobs like this, that means over time we get that sort of combinatorial explosion that we've shown, right? How many input booleans can you have? So what I think is important, because in the end we don't want to allow a 1500 MTU in our network. We just want the 9100. So what we want to do here is focus on the transition, right? And thus we arrive at this, which is just the example that we had before. We have this, it's a feature flag, we sorted it in under this nice container. We have a leaf, we call it high MTU, which is very much, focused on that transition on the feature. We want to enable the high MTU. It's a simple choice, it's a boolean, right? And so this is how you build a feature flag. So when we talked about testing earlier, we focused on the total number of inputs and how we, with a naive change, keep down the amount of test cases. So that's only partly true. With our naive perspective on the world, the change is an atomic one, right? So we go from the old value of 1500 to the new value of 9100, and it's sort of transactional and atomic. You change the config template, you commit it in Git, right, and then you have the new value. Reality, however, is a little bit more nuanced than that. If you actually look at how this is going to work out, right, in your network, you start out, all the service instances are using 1500. You change the service, so the template. Then you start your deployment. So when the very first instance is redeployed or the feature flag is flipped, that means you now have a mix of 1500 and 9100 in your network. And as you keep deploying, you still have a mix. And at some point, when you've redeployed or flipped all the feature flags, you have reached where all the servers are done, and we now have a 9100 MTU in the network. So the change is deployed. What we see and understand here is that it's not an atomic change, right? There are actually 3 stages to it. So if we want to cover this properly with test cases, we will want to have test cases for, well, all of these 3, right? So we got to do a mix. And if you think of how to implement that, you'll realize it is actually much easier to do this if we have a feature flag. So we can test a mix in the network where some instances of the service have the old value, the feature flag is turned off, and some instances where it's turned on. And we can also test the feature flag transition itself, so you can test flipping it. If you instead consider doing this with a naive change, implementing that, the very test of it in CI is quite difficult because you have to load multiple versions of the package, and that's just hard. So adding these tests, they do increase the number of test cases. I mean, that goes against what I said before. We want to keep that down. But what's really important is to keep down the number of test cases over time. And this is why we have feature flags that have to be removed once we're done with it. So, we introduce the feature flag. We have to add some test cases to cover the old value, the new value, and the sort of transition and mix in between. But once we're done with it, we can remove it. So and get back to that lower level of test cases, which makes you ready for the next sort of transition, right? I mean, if we say if we're normal at 15 test cases, our budget, so to say, is 20, then we can afford to have a feature flag. We're done with that. We're back at the level of 15, and now we have the budget to sort of do another test case. But if we just keep expanding with more and more and more configuration knobs, then soon we're at not, and I mean, remember how this scales, right? So if we add just a couple of these and go up to like 6 or 7, then all of a sudden we're up at 60 or 120 test cases, and we really can't afford to do that, right? So I think it's overall a very good idea to add test cases for when you add a feature flag. That's the only way to do it in a controlled and robust way. It does mean you increase the amount of tests, so you get a bump sort of in that level, but it is worth it. And once you're done with the change, then you remove the feature flag and you also remove the test cases, and so you're back at that lower level. So to summarize all of this, right, I think that change is a very natural part in the life cycle of a service. If you go out and look at any network, any service provider, any company really that have any form of service that they offer, and you ask someone, I mean, are you standing still, or are you improving? Are you evolving your service offering? Everyone is going to say that, of course, they're evolving, right? And if you're evolving, that means you are changing things. So we really have to embrace change. We have to be good at handling change. And I think automation is to a large degree about being very good at handling change and doing so in a robust manner. So for operations, robust operations, we have to have control when we change something. We can't just blindly shoot things out. We have to know what we're doing. We have to have control over it. And feature flags is an excellent way to gain control over the changes that you're trying to implement, right? When you implement feature flags, focus on simple choice. If you ever think that you need something with more choices than a Boolean, I think you need to rethink simply. I've seen cases where people wanted to do transitions, so we have sort of the old value, you have the new value, and then someone wants to introduce the new value. And to me, this just indicates that you're not done doing the first transition, and you're already trying to implement the second transition. So it's better keeping it simple and actually, I mean, you got to have the operational rigor to actually push that change out and get it done right. But that allows you to have a simple choice, typically Booleans. You want to keep the transitional nature. Again, it's been mentioned here a couple of times. We have to be able to test things with a reasonable effort, and keeping down the amount of test cases is really the only way of doing that. And in order to do that, we have to just introduce the feature flags for the period of the change itself. Then they got to go. Okay, and with that, we conclude the first part, covering sort of feature flags and how they help us introduce change. So for the second part, where we're going to focus on the phase rollout part. So phase rollout means that we handle the rollout, in this case, a configuration change, with a phased approach. So instead of applying a single transaction and pushing all that configuration at once, we just do a small piece at a time. So this way, if anything goes wrong, we can stop the rollout and then we can start reverting that bad change, right? So it prevents a major impact to users. While, I mean, to the user group that you deploy this, there's obviously going to be an impact. They're going to be negatively affected by this bad change, but the impact should be relatively contained if we've done this right. I have some numbers here of 5, 20, 50, but I mean, in reality, if you have thousands of services, it's more likely you're going to start with a single instance, and then you grow this very, very slowly. So it's going to be just a very small percentage at a time. So just how do you actually do a rollout of a change? So if we're doing the naive approach, after we've changed the service and reloaded the package in NSO, all we have to do is a redeploy of the service instances. If there are hundreds of instances here, NSO will just nicely go through each and every one of them and do a redeploy. I mean, the wildcard takes care of this for us, and it just starts looping them over. NSO will not do this in a single transaction, but rather NSO will use one transaction per service that it redeploys. Now with the feature flag approach, instead of just redeploying the service, we go in and we flip the feature flag and then we commit. So this then has to be repeated for all the service instances that we have. And here we get some more control because we can choose how many services we want to flip the feature flag for in a single transaction. In the example here, I've done it for one service instance, but you could do it for 3 or 5 or 300. It's all up to you. I mean, you can even do it for all the instances that you have, which then would mean you do the change in a single transaction. But that's generally not what we want here, because we want to do it in small increments, right? Now, regardless if we're taking the naive approach or the feature flag approach, there is the challenge of error handling. So when doing a configuration change, the only type of errors that you can catch are syntax and semantics checks. So these are the ones that are sort of related to the configuration directly, and a lot of these are actually captured already in Yang. So perhaps it won't even be possible to load a configuration template with invalid values, etc. But let's just say that we're past that part. Now, a syntax error is something like trying to enter a string where an IP address is expected. Semantics checks could be, I think, referential integrity is one of the more common ones. So that's like where we have an access list that's being attached on an interface, and then we try to remove the access list. That's invalid configuration, right? Because we're referencing something, then we can't remove it. If we try to push configuration that breaks either syntax or semantic checks and violates them, then this will be rejected by the device. And NSO will notice this, and the transaction will be aborted. But consider that an empty configuration is valid configuration. It will pass all syntax and semantic checks, right? It's quite obvious to you and me that if you push an empty configuration, then the service or the device or the service will be unhealthy. It won't work as the way it was intended. So let's just say that the feature flag we implemented, it actually breaks the service so badly that instead of pushing the normal configuration, it's going to push an empty configuration. This will not be noticed by NSO, right? It would be perfectly valid for NSO to push this and would not result in any error. But clearly, it would lead to the service no longer working as intended. Now, if you think of the broader sort of procedure here, what you do with feature flags, that for each service instance, you'd flip the feature flag, you'd commit that, and now consider the failure mode, or what happens is, which is really nothing, right? So you have the first instance, you push that configuration, it fails, but you don't notice. So then you go on to the next one, and you push that, it fails, and no one notices it, and the third, and so on and so forth. And it's just all aboard the fail train. So in particular, if we implement, let's say, some more automatic functionality, maybe we have a script that talks to NSO and runs a rollout automatically, then there's nothing stopping it. It's just going to continue service instance by instance and slowly but surely ruin our network. So what we need is the concept of a success condition that goes beyond the basic configuration validity. And I think what we need to have as a concept is service health. So we need to understand if a service is healthy. Healthy is not the same thing as being configured. I mean, we can configure a BGP neighbor, but just because it's configured doesn't mean that it's up, that it's receiving the right routes, that it's advertising the right routes, right? So in order to determine that it is, what we have to do is monitor the operational state of a service. So if we're configuring a BGP neighbor, we want to make sure that the BGP neighbor is up. Then we want to make sure that it's advertising the right routes and that it's receiving the correct ones. If it's a service that configures an interface, then we want to do the same thing. I mean, we want to check the interface being up, maybe check that there's a routing protocol running. Maybe we want to check that we can ping, things like that. And these all become service specific. These cannot be generic. So it's something that you have to implement. At the same time that you're implementing your configuration side of a service, you should also be thinking of implementing the operational state side of it, monitoring the operational state. And while there are commonality here, I mean, if we have a service configuring BGP peering partner, another one configuring BGP customer, you have a common part in that you want to make sure that the BGP neighbor is up. So that could probably be shared in code, but you want to advertise a different set of routes to a peering partner versus a customer. So this still has to become service specific. It's the service itself that carries the intent of what you want to have done. And with that as a context, I mean, since we have state, and Sociotechnical has a state for each service, we have that context. We know what a particular BGP neighbor should be doing. And that is what truly makes NSO a good platform to build this sort of operational state monitoring that is service oriented. So how do we actually do this in reality, right? I think the easiest way is to implement this through a Yang action. So what you do is implement the self-test action. We can see here we have our list of backbone interfaces. Now I've removed the feature flag and all the other stuff, and we're just going to focus on the action. So action is a keyword in Yang, right? And we're going to call our action self-test. You could call it whatever you want, but self-test is a good name. And we see how we tie it in here with an action point. We're going to look in a second how the code behind this looks. Now this is the output, so this is what the action is going to output. And a very important aspect here is that we return a common data structure. The leaf success here is common. So all the self-tests that we have in our system, all of them will return this success leaf. There's also more data being returned. So this is a backbone interface. So we return some information about the interface, the physical interface. We return information about ISIS, which is the routing protocol in this case, and then PIM, which is the multicast routing protocol. But in order to sort of read these out, you have to be aware of which type of service it is. And that's the unique quality by having this common return structure. Because regardless if this is a BGP service or an interface service like this, we're always going to get that success leaf. So we don't actually have to understand what type of service it is in order to know if it's healthy. If it returns the success leaf and it's true, then the service is healthy. Also notice that this lives under each service instance, right? So when we run a self-test, we run it on a particular instance. This is an example, a very, very simple example of the sort of Python code that you could hook in underneath this action, right? So what happens here is that we have the callback, the action callback. We're getting fed some input. We're gonna, among that is the key path to our service instance. We're gonna dig that out as a magic node. We then get the device, which is the service.device is part of the key to the service, right? So we get a reference here to device's device and then our device. We get the operating system. We look at the operating system. If it's Nokia SROS in this case, we have some utilities here, right? That finds out the operating system and get DevOS. So if it's Nokia SROS, then we're going to grab the interface, which in turn, now we go down under the device in live status. So now we're fetching operational state. We go to the router base, it's called Nokia, and then the interface, and here we grab the interface that's for our specific service instance, right? On the interface, we look at the operational state and see if it's up, then the success leaf is going to be true. So what we're doing here is just reading live status from the device. We evaluate this operational state to see if it's as per our expectations. And if it is, we set the success leaf and we return. Now, with a self-test in place, our modified procedure looks like this. So starting from the top here, we have a list of our service instances. We grab the first one from the list. We then proceed to check if the service is healthy by running the self-test. So if it's unhealthy, we get a success false back. That means we can probably skip the service instance, but there's no point in trying to enable the feature flag if the service is currently unhealthy. We could also choose at this point to just pause the entire rollout. But let's say that we skip this one, right? So that means we jump over here and go to the next instance, get the next one from the list. This time around, we check the health, run the self-test, and it's healthy. We're then going to proceed to flip the feature flag. And after the feature flag has been flipped, we can now rerun the self-test and see if the service is still healthy. If it's unhealthy, so we get a success false back, that obviously means that our change is a bad one, right? So we need to flip back the feature flag and leave it be. Again, you're left with the choice: do you want to continue the entire rollout, or do you want to stop the process once you see a bad change? On the other hand, if you do you flip the feature flag, you check the health after, and you see that it's healthy, that means everything did go well. Then you can go to the next instance and repeat the entire process, and you just keep repeating this for in this case, 400 instances of the backbone interface service that we've been looking at, right? And I mean, you can imagine having a sort of a policy to determine the actions that you want to take on failures. Maybe you want to allow for a few failures, but if you see a lot of consecutive failures, then you want to abort immediately. Now, flipping feature flags like that and running self-test, that's a monotonous task, not something we humans are really good at and don't really enjoy. So I'd say it's a task for a computer. So I think there should be a package, an NSO package to help out doing this. It doesn't exist to my knowledge, but I think it should exist. So if you're interested in this area, reach out to me, right? And I think that it should contain two features or two primary areas that it should work in. So it should be able to summarize the feature flag rollout that we have, so sort of the progress of rolling out feature flags. And it should also allow to run the automatic procedure that we just looked at. So flipping feature flags in a controlled manner by interleaving it with running self-test, right? And here I've built this, it's a sort of a mock-up of its feature flag navigator, as I call it. So at the top here, we can see we have this show feature flags command, which lists the feature flags that we have and the progress. So we can see these are rolled out to 73% and 14% respectively. They are feature flags in different services. So this is on base config, it's called foo bar, and this is on the backbone interface, it's called bar. Then the second command here actually shows all the instances that we have. So for the base config, we have two instances of this service, 2053 and 2054. So the foo bar, right, and the values here are false and true. So I mean, as you see, this is a mock, right, because this doesn't add up to the progress listed up here, but I think you get the idea. We also have a column for type. So far, I've talked about using a Boolean leaf. I think it's good to have sort of a uniform feeling to it. I think it's good to start out having a default value of false, and the transition should always be positive, so you enable the feature. But I mean, it's theoretically possible, at least, that you want to flip this around and actually have a change where the feature flag goes in the other direction. So we start with the true value and we disable it. So this column could capture that. But again, it's just a mock-up, right? So if you're interested, please reach out. And to summarize, right? I mean, change, natural part in the life cycle of a service. We have to embrace it. We have to be very good at it. And above all, for robust operations, we have to have good control over the changes that we do. Use feature flags to gain control. Focus on a simple choice. Focus on the transitional nature. And then, since we have a lot of feature flags, we have to use phase rollouts and automate that phase rollout. In order to do so in a robust way, we have to look at service health. So we know that we're not actually breaking anything, right? So look at phase rollouts through service health and automate the rollout by flipping feature flags, right? Okay, thank you very much for listening. Thank you.